Hello friends and my dear students, I welcome you all to my channel. I hope you are all well and your studies are also going on well. I have prepared a test, a revision test on the chapters of polygons, quadrilaterals and parallelograms. This is test number 1. So from now onwards, I will prepare and solve tests which will cover a few chapters. This will be a part of your revision. So this test number 1, chapter test number 1 will have problems on polygons, quadrilaterals and parallelograms. I have already covered these topics in my theoretical videos under the in the same playlist. You can, if you want to revise the concepts, you can please watch those videos on polygons, quadrilaterals and parallelograms. Ideally you should be this test consists of 10 MCQs and ideally you should be able to complete it in 45 minutes. So this video is part of the playlist CBSE Maths for class 8 following the textbook of author R.S. Aggarwal. If you are new to my channel or not yet subscribed, and if you are watching my videos regularly and my videos are beneficial to you, then I strongly suggest and request that you please support me by subscribing to my channel. And also do not forget to press the bell icon so that you will be notified by my future videos. So let's get started with the chapter test number 1 on the chapter of polygons, quadrilaterals and parallelograms. Okay, so I have the chapter test number 1 problems on the left hand side. I hope the fonts are big enough so that you can read them properly. The PDF, the link of the PDF of this problem set will be given in the description below. Always try to give the test and solve the problems yourself. Ideally, you should be able to solve the problems, 10 MCQ problems in 45 minutes. If you are stuck at any problem or you want to see my solution, then please do watch this video for my solution. But please note that there are many ways of solving a problem in mathematics. There are multiple ways of solving a problem. So I will use my way based on my concept and understanding. You need not follow my way or solution exactly. If you have a better solution, then please go with your own understanding, concept and solution. Okay, so let's start solving the problems. Problem number 1. Problem number 1 says that in a parallelogram PQRS, parallelogram PQRS, angle S is 105 degree. If angle P plus angle Q divided by 2 is equal to K multiplied by 45 degree, then the value of K is. So first of all, roughly draw the parallelogram PQRS. Now all the drawings that I will draw, it will be a rough or approximate diagram. It will not be a perfect one. So let's say this is PQRS is a parallelogram, and so it is given that angle S is 105 degree. So this is 105 degree, it is given. Okay, and angle P, it is given that angle P plus angle Q divided by 2 is equal to K, must be some constant, we have to find K, multiplied by 45 degree. What is the value of K? So PQRS is a parallelogram. Okay, now if PQRS is a parallelogram, so PQRS, always try to solve a problem using the very fundamental concepts of the fundamental related concept. So in a parallelogram, so we know that it is given that PQRS is a parallelogram. So immediately we can say that angle Q will be equal to angle S, as they are a pair of opposite angles, and so this will be equal to 105 degree. Angle S is given to be 105 degree. So we have angle Q is equal to 105 degree. Okay, we have to find now P. What is P? Also we know that well, I don't think AC is required. This is not required at all. we can find straight away the value of P plus Q. Why? We know that PQ, since PQRS is a parallelogram, this will imply that PQ is parallel to SR. PQ is parallel to SR. No, P plus Q, this angle. Yes, and no, sorry, not PQ. We know that PQRS is a parallelogram, so we must have PS parallel to QR. PS is parallel to QR, and PQ is a transversal. Well, I think directly we can say, what I am trying to say is that angle P, angle Q are adjacent angles, and since PQR is a parallelogram, we know that in a parallelogram any pair of adjacent angles are supplementary, that is their sum is 180 degree. So we must have angle P plus angle Q is equal to 180 degree. So this implies that angle P plus angle Q divided by 2 should be equal to 180 degree. 180 degree divided by 2, which is 90 degree, which is equal to 2 into 45 degree. Now it is given that P plus Q. So if I consider this to be result 1 and this to be result 2, so we can say 1 and 2 implies that K has to be equal to 2. So the value of S, the value of angle S, it is given, but it is not necessary to solve the problem. So it is given just to confuse the candidate. So always read the problem and understand what is given and what it is asking. So what information is actually required to solve the problem. Sometimes it will give some extra information which is not actually required to solve the problem, just to trick the student. Anyway, so K is equal to 2. So the correct choice is B. If I am making, please note that I have no idea what are the answers. I have not seen the solution. I have not seen the answers. So I am just solving randomly right away. So I could be wrong in solving any problem. If that is so, if I am making any calculation mistake or I am applying some wrong concept, please do let me know in the comment section. I will highly appreciate that. Okay. I will quickly check if everything is visible or not. Okay. Let's do problem number 2. Problem number 2 says, if the exterior angle at a vertex of a rhombus is 96 degree, then the possible angles of the rhombus are, some choices are given. Choice A is telling that the 4 angles are 84 degree, 96 degree, 84 degree, 96 degree. Okay. B is 96, all are 96 degree. Now sometimes you will see that some choices you can eliminate some choices right away. For example, in this problem, choice B and choice C cannot be the answer, because if for choice B, if all the angles are 96 degree, it means that 96 degree, the sum of all the interior angles will be 96 into 4 degree, which is no way equal to 360 degree, because we know that a rhombus is a quadrilateral and the sum of the interior angles of a quadrilateral is always 360 degree. So choice B is definitely not the correct choice. Also similarly, you will see that choice C, all the given angles are 84 degree. So 84 degree multiplied by 4 is not equal to definitely 360 degree. So the answer will be either choice A or choice D. Now choice D is saying no rhombus has now I can easily find the answer by drawing a rhombus and solving it mathematically. But sometimes you will see, sometimes the actual answer will be you can indirectly find the actual answer by eliminating all the wrong answers. That is what I am trying to address here. Now, choice D, so this cannot be correct answer, this cannot be a correct answer. D, it is saying that no rhombus has obtuse exterior angle. It is saying, choice D is saying that in all the rhombus, in any rhombus, an exterior angle cannot be obtuse. This is wrong, because I can easily draw a rhombus where now exterior angle obtuse means its corresponding interior angle will be acute. I can always draw a rhombus. So this is the rhombus, all the sides are equal, as you can see. This is the rhombus where this angle is acute. Let's say, I don't know, let's say this is 30 degree. So this is interior angle acute. So its exterior angle will be this, and this is definitely greater than 90 degree. That is obtuse. So a rhombus, exterior angle of a rhombus can always be obtuse. So this is wrong. So the only choice we are left with is A. A is definitely the right choice, but we have come to the conclusion that A is the right choice because we have confidently eliminated the choices B, C, and D. Now let's see how how we can directly solve this problem. So it is given that there is a rhombus. Let's say I'm roughly drawing the rhombus. If the exterior angle at a vertex of a rhombus is 96 degree, which 96 degree is obtuse, so it will be so greater than 90 degree. So my diagram is not correct. Anyway, please assume that this is 90 degree, even though this is 96 degree. Let's say this is 96 degree. This is an exterior angle. Now it could be any exterior angle. Just for the sake of discussion, let's say the rhombus is ABCD, and let's say this is the exterior angle, which is 96 degree. We know that the exterior angle and the corresponding interior angle, they are supplementary. That is, their addition is, the sum of their values is 180 degree. So this angle, so angle A has to be 180 degree minus 96 degree, which is equal to I guess 84 degree, 10, yes, 84 degree. So this is 84 degree. Now if it is 84 degree, definitely since rhombus is a parallelogram, its opposite angle C, it will also be 84 degree. And also the angle B and angle A are adjacent angles, and this is a parallelogram. So so angle A and angle B will be supplementary, and so angle B will be 96 degree. So clearly we can see that the angles are 84 degree, 96 degree, 84 degree, and this will also be 96 degree. So this way we could have directly solved the problem. So the correct choice is answer A. A is the correct choice. Okay, let's do problem number 3. The measure of each interior angle of a regular polygon with least prime number of diagonals is. The measure of each interior angle of a regular polygon. Okay, so the polygon is a regular polygon. The measure of each interior angle. First of all, we know for a regular n-sided polygon, for a regular n-sided polygon, we know that each interior angle, I am abbreviating interior angle as IA, is equal to 180 degree multiplied by n minus 2 divided by n. We know this formula. Okay, it is asking what is the measure of each interior angle of a regular polygon with least prime number of diagonals. With least prime number of diagonals. Okay, So what is the formula for number of diagonals? I'm abbreviating NOD as number of diagonals. We know that number of diagonals in a polygon of n side is n into n minus 3 divided by 2. This is the number of diagonals in a polygon of n sides. So the regular polygon will have the number of diagonals which is a least prime number. Least prime number. Now the least prime numbers, the prime numbers are 2, 3, 5, 7, 11 and so on. So the least prime number is 2. Now, okay, so the number of diagonals of the polygon, it is saying that is 2, because it is saying that the number of diagonals is the least prime number. So this has to be equal to 2. So we have to solve n from here. Can we solve n? So this implies that n into n minus 3 is equal to 4. Is equal to 4. Okay, so this implies if you do a little bit of basic mathematics, what can be the value of n such that n into n minus 3 is 4. This will be equal to 4. This will be equal to 4. Now this, why we have taken n into n minus 3 divided by 2 equals to 2, because n into n minus 3 divided by 2 is the number of diagonals in a polygon of n sides. It does not matter whether the polygon is regular or irregular. A polygon of n sides has n into n minus 3 divided by 2 number of diagonals. Now it is saying, it is given that the number of diagonals in the problem, it is given that the number of diagonals is the least prime number. So 2 is the least prime number. So I have equated n into n minus 3 divided by 2 equals to 2. From here I am trying to find the value of n. What can be n? So n is equal to 4. So therefore the polygon is, so we have found that n equals to 4. Okay. So now this implies we now can easily find what is the interior angle. Interior angle will be 180 degree, n is 4. 4 minus 2 divided by 4. This is 180 degree. So 180 degree multiplied by 2 divided by 4 to 90 degree. So 90 degree. So so since it is obvious because n we have found to be 4. And the regular polygon, a regular polygon with number of sides 4 is nothing but a square, and we know that every angle of a square is 90 degree. Okay, so the answer is choice B. Okay, let's do question number 4. Question number 4 says the number of sides of a regular polygon whose each exterior angle is an obtuse angle is the number of sides of a regular polygon. Okay, so we are dealing with a polygon which is regular. The number of sides, it is asking the number of sides whose each exterior angle is an obtuse angle. Okay, so what do we know? For a regular n-sided polygon, for a regular n-sided polygon, we know the formula is each exterior angle, I am abbreviating as I am abbreviating as exterior angle. So EI means exterior angle, that is exterior angle. Okay, is equal to, we know 360 degree 360 divided by n, this much degree. Now this is the each exterior angle for an n-sided regular polygon. So this is n-sided regular polygon. Now this angle has to be obtuse. It is asking the number of sides of a regular polygon whose each exterior angle is an obtuse angle. This will be obtuse, meaning obtuse angle, we know that obtuse angle, what is an obtuse angle? Obtuse angle is greater than 90 degree, we know this. So this will this will imply that if we consider that the regular polygon has n sides whose exterior angle is obtuse, so we must have 360 by n degree. This must be greater than 90 degree. This must be greater than 90 degrees. So we have to solve now for n. So this is a kind of inequality, even though you have not studied inequality, but it is a good choice if you know a very basics of inequality. Let me first solve the problem, then I will explain a little bit about the inequality that I will apply in solving this problem. So from here, what I will do is that, you know, in solving a linear equation, you can multiply both the LHS and RHS by a non-zero number. In inequality also, by non-zero number, that has to be by non-zero number if it's an equation equality. But in this equation is not equality, it is an inequality, because we have the greater than sign. It could be also less than sign. In greater than sign or less than sign, so I can multiply both the LHS of this equation. So this is, let this equation be 1, not equation, this is an inequality. I can multiply both the LHS and RHS by a positive non-zero number, and that positive non-zero number I am multiplying is with n. We know n is a number of sides of a polygon. It is always greater than or equal to 1, and it is a natural number. So I can always multiply this and rewrite the inequality like this: n multiplied by this should be greater than n multiplied by 90 degree. This implies from in the left hand side n will get cancelled, so we must have 360 degree should be greater than n multiplied by 90 degree. From here, what I will do again is I will divide, I can also divide inequality by the same non-zero positive number. Non-zero positive number, this is very important. So I will now divide both the LHS and RHS by 90 degree. So this becomes 360 degree divided by 90 degree should be greater than n. Now if I simplify the LHS, it is 360 degree divided by 90 degree is nothing but 360 by 90 divided by n. This implies 360 divided by 90 is 4. So 4 is greater than n. 4 is greater than n, or we can write as n is less than 4. N is less than 4. Now what is n? N is the number of sides of the regular polygon. We know that a polygon, the minimum number of sides in a polygon is always 3. So n is always greater than or equals to 3, and we have found that n is less than 4. So this implies n has to be equal to 3. N has to be equal to 3. So because we also know that n has to be greater than or equal to 3, because n is the number of sides of a polygon, and the minimum number of sides in a polygon is 3. So n is 3, and hence the correct choice is C. The correct choice is C. Okay. Let's do question number 5. ABCD is a parallelogram. Now remember that this notation is a short form of writing parallelogram. This means parallelogram. This is a shorthand notation. Okay. So ABCD is a parallelogram whose diagonals intersect at an angle of 65 degree. ABCD is a parallelogram. Okay. It's a parallelogram and the diagonals are intersecting at an angle of 65 degree. If AC is equal to BD, let me quickly draw a rough parallelogram. A, B, C, D is a parallelogram. So definitely we know the opposite sides will be parallel. Okay. And the diagonals AC and BD, it is given they are intersecting at 65 degree. Okay. If AC is equal to BD, that is the diagonals are equal, then the value of angle A plus C, then the value of angle A plus C, A and C are vertically opposite angles, opposite angles in the parallelogram. The diagonals are equal. Now in a parallelogram, if diagonals are equal, so ABCD is a parallelogram, and diagonals AC equals to BD means the diagonals are equal, and diagonals are equal. When in a parallelogram the diagonals are equal, then the parallelogram can be it can be a square, it can be a square, it can be a rectangle. This implies that ABCD can be a square, or it can be a rectangle, because in square and rectangle we know that square and rectangle are parallelograms where the diagonals are equal. Also it can be a rhombus. In a rhombus the diagonals can also be equal. In a rhombus the diagonals need not be equal, but if in a rhombus the diagonal becomes equal, then it will be a square. So if in a parallelogram the diagonals are equal, we can say that it can either be a square or rectangle. So in any case it can be a square or rectangle. Now why is the angle 65 degree is given? The angle of intersection of the diagonals is 65 degree. This means that so the diagonals are not, ABCD is a parallelogram and diagonals are equal. And also what information we are having, let me first so we are having ABCD is a parallelogram and diagonals are equal, and we can also see that diagonals are not intersecting at right angle, are not intersecting at 90 degree. So what can we say about the parallelogram ABCD? In a square the diagonals intersect at 90 degree, so this is not a square, since in this figure it is given the diagonals are intersecting at 65 degree, which is not 90 degree, so it will not be a square. It will not be a rhombus. So definitely it has to be a square. So we can directly say that this is a rectangle. This is a rectangle. So this implies, if this is a rectangle, we know that all the angles of a rectangle are 90 degree. So we can say that angle A is equal to angle C is equal to 90 degree. So this implies we are asked to find angle A plus angle C. So angle A plus angle C will be equal to 2 into 90 degree, which is equal to 180 degree. So ABCD is a rectangle, and obviously the sum of angles A and C will be 90 plus 90, that is 180 degree. So the correct choice is B. B is the correct choice. Okay, let's do question number 6. ABCD. ABCD and BDCE are parallelograms. ABCD and BDCE. Okay. Let me draw the diagram large enough so that it will be easy to mention the angles and label the angles. Okay, so we have kind of. Okay, so A so A I'm roughly drawing the diagram. So ABCD, A P C D is a parallelogram and BDCE is a parallelogram. Okay, with common base DC. Okay, so DC is the common base and BD is perpendicular to BD is perpendicular to BC. BD is perpendicular to BC, so my diagram is not at all perfect. Anyway, let's say even though my diagram is very bad, let's say this is 90 degree. So this is 90 degree. Okay, and angle A is 30 degree. So this is given to be 30 degree. Then value of x is, what is x? Okay, so this angle E is labeled as x. We have to find x. What is the value of x? Okay, so x will be a number. The angle A is given as x degree, so x will be a number value. We have to find x. Okay, this is 90 degree. Okay, this is 30 degree. A is 30 degree. Okay, so if A is 30 degree, what we can have in parallelogram ABCD, we must have angle A is equal to angle C. This will be equal to 30 degree. Okay, so we have this should also be 30 degree, as angle A and angle C are opposite angles in the parallelogram ABCD. Okay, what can we, how do we find x? Okay, so B, okay, now in triangle BDC, we know that one angle is given to be angle DBC is given to be 90 degree. So this implies, from the angle sum property of a triangle, we can say that angle BDC plus, that is the sum of the other two angles, BCD should be equal to 90 degree. This implies, now BDCE is also a parallelogram, so E and D are in parallelogram BDCE. Angle E and angle D are opposite angles, so they both must be equal to x degree. So we have angle BDC is nothing, angle BDC is this will be also x. So we have x degree plus what is angle BCD. Angle BCD is given to be 30 degree. 30 degree is equal to 90 degree. So this implies x degree is equal to 90 degree minus 30 degree, which is equal to 60 degree. So this implies x is equal to 60. So the value of x is 60, and hence the answer is, the correct choice is A. A is the correct choice. Okay, let's do question number 7. The angles PQ, R and S of the quadrilateral PQRS are in the ratio 1:3:7:9. Then PQRS is a, okay, it is asking then what is the structure of the quadrilateral PQRS? What is its shape? Is it a parallelogram, kite, or trapezium? Okay, the ratio of all the four angles are given in a quadrilateral, and we know that the sum of all the angles in a quadrilateral is 360 degree. We can easily find out all the angles, and from the angles we have to see, based on the angles we have to see, we have to identify the quadrilateral. Okay, so let's say since okay, let's say this is the, I am roughly drawing a quadrilateral. Okay, so PQRS. So P, let's say PQRS is the quadrilateral. Okay, so I will, you know that when a concept from ratio and proportion, if we are given that, let's say x is to y, x and y are two quantities. If the ratio is given, let's say p is to q, where p and q are some numbers. If x is to y is equal to p is to q, and it is given that x plus y is equal to a, we can directly find the values of x and y. So x will be p by p plus q, this whole multiplied by a, and y will be q q by p plus q whole multiplied by a. So using this concept, now this is the ratio between two quantities x and y. It can be more than two quantities. The concept, the formula will be same. So it is given that angle P is to angle Q is to angle R is to angle S is given to be 1:3:7:9. So applying the concept on the right hand side, I can say that angle P will be 1 by the sum of all the parts in the given ratio is 4, 11 and 20. 1 by 20, it will be 1 by 20. 1 is the part of the angle P. 1 by 20 multiplied by, we know the sum of all the angles is 360 degree. 360 degree. So this is equal to 18 degree. Angle P is 18 degree. Okay. What will be angle Q? Angle Q will be similarly 3 by 20 multiplied by 360 degree. Now this will be definitely 18 degree multiplied by 3, which is equal to 54 degree, which is 54 degree. Similarly, angle R will be 7 by 20 multiplied by 360 degree. This will be 18 degree multiplied by 7, which is 126 degree. And S will be 9 by 20 multiplied by 360 degree. This will be 18 degree multiplied by 9. This is 162 degree. 162 degree. Okay, so we have, I hope I did the calculation correct. The sum of the parts is 20. So 1 by 20 multiplied by 360 degree is 18 degree. Okay, so P will be 18 degree, Q will be 3 into 18 degree, that is 54 degree. R will be 7 into 18 degree, that is 7 into 18 degree, which is 126 degree, and S will be 9 into 18 degree, which is 162 degree. Okay, so we are having P as 18 degree, S as 162 degree, 162 degree, and R is 126 degree, 126 degree, and S is 162 degree, and Q is 54 degree. Q is 54 degree. So all the angles are different. All the angles are different. So definitely this is not a parallelogram, because P and R, if it was a parallelogram, then P and R, P should be equal to R and S should be equal to Q. This is not the case. Is it a kite? In a kite, we know that two angles are, in a kite, one pair of opposite angles are equal. So this is not also a kite. A trapezium with P PQ parallel to RS. Okay, it must be between B and D, so it has to be a trapezium. Now, trapezium. Trapezium with PQ parallel to RS. Now we have to see if if it is a B. Now I have to see case by case. I mean, I have to individually see if choice B and D are correct or not. Now, if B is correct, then it is saying that it is a trapezium with PQ parallel to RS. PQ parallel to RS. If PQ is parallel to RS, then definitely the sum of P if PQ is parallel to RS, RS, then definitely we must have the sum of if PQ is parallel to SR, this will imply that PQ parallel to SR, and we are having two transversals, PS and QR. If we can, so we must have angle P plus angle S should be equal to, they should be supplementary, and also angle Q and angle R should be supplementary, and their sum should be equal to 180 degree. We have to just check this. Angle P is 180 degree and angle S is 162 degree. So definitely we can see angle P and angle S is 180 degree. Also Q and R, their sum is 180 degree. 180 degree. So we can say since angle P plus angle S is equal to angle Q plus angle R is equal to 180 degree, this implies that PQ is parallel to SR. So this implies that it will be a trapezium. ABC PQRS is a trapezium. It is a trapezium with PQ parallel to SR or RS. So the correct choice is B. B is the correct choice. This was a bit so far a little complex and tricky problem. Okay. Question number 8. ABCD is a quadrilateral. Bisectors of angle B and angle D meet CD. Okay, so let me first draw the parallelogram. ABCD is a quadrilateral. Oh, it is not a parallelogram, it is just a quadrilateral. Okay, bisectors of angle B and angle D meet at CD and AB produced at P and Q respectively. BPC, angle BPC is x degree, angle DQA is y degree, then value of x degree plus y degree is AB and CD are produced to Q and P. Okay, so this is the line and this is the line. So let's say this is AB. I don't know what kind of quadrilateral ABCD is. Anyway, AB C D. Okay, ABCD is a quadrilateral. Fine. Bisector of angle B and D meet CD and AB produced at P and Q. So bisector of angle B meets at P, which is meets at P. Okay, so kind of this. So this point is P, which is obtained by producing the side CD. Okay, so this is x degree, and so this angle is equal to this angle. as BP is the bisector of angle B. Okay. Similarly, it is saying the bisector of angle D is meeting AB produced at Q. Okay. So kind of this. So this angle is equal to this angle, and this is Q, DQ. It's the bisector of angle D, and BP is the bisector of angle B, and this is labeled as y degree. It is asking to find BP's, it is asking to find the value of x degree plus y degree. It has asked to find x degree plus y degree. Now sometimes it is not, now even if maybe we need not find individual values of x and y, somehow we can find the value of x plus y. Okay. So what information do we have? What do we have? ABCD is a normal quadrilateral. So ABCD is a normal quadrilateral. X plus y, x plus y. X plus y. X degree. What is this? This is x. Now in quadrilateral BP DQ, in quadrilateral BP DQ, we must have, it is a quadrilateral, we must have x degree plus y degree should be, we must have x degree plus y degree plus angle PBQ plus angle PDQ should be equal to 360 degree. Since the sum of all the angles in of a quadrilateral is 360 degree, we have this. Now can we find angle PBQ? Angle PBQ. Angle PBQ. Oh, the choices are given in terms of angle A, C, B, and D. Oh, okay. So the choices are given in terms of A, B, C, D. Okay. A, B, C, D. Now what is angle? What is what is angle PBQ? PBQ is angle let's say the each bisecting angle of the angle B, let's say the angle B has been bisected by the BP, and let's say each of the bisecting angles, let's say is m degree. So this is m degree, this is m degree, and also let's say the angle D is bisected into two equal angles, n degree and n degree. So now what is angle PBQ? PBQ will be m degree plus angle CBQ. M degree plus angle CBQ is this angle. Now what is angle CBQ? What is angle CBQ? We can say angle CBQ is 180 degree minus twice of m degree. Angle B of the quadrilateral ABCD is nothing but twice m degree. So CBQ is equal to 180 degree minus twice m degree. This is equal to 180 degree minus m degree. Okay, PBQ. Okay. And similarly, what is angle PDQ? PDQ. Angle PDQ will be similarly equal to 180 degree minus n degree. So this angle is PDQ. Obviously, it will be 180 degree minus n degree. Okay, so we have this. Now, if I so let's say this be equation 1, and let's say PBQ is now putting values of angle PBQ and PDQ in 1. What do we get? It was one was x degree plus y degree plus angle PBQ. PBQ is we have found to be 180 degree minus m degree, and what is PDQ? 180 degree minus n degree. This should be equal to 360 degree. Okay, so we have this. So this implies x degree. If we simplify the left hand side, we have x degree plus y degree, 180 360, and we have minus m degree minus n degree is equal to 360 degree. So this implies 360 degree will get cancelled out from both sides. Okay, so we have x degree plus y degree is equal to m degree plus n degree. Okay. Now what is m degree? What is m degree? M degree is the half of angle B. So m degree is half of angle B. Similarly, n degree is half of angle D. Angle D. So this is half of angle B plus angle D. I see. I don't know whether my solution is lengthy. It's a roundabout. Maybe there is a better, easier and straightforward solution. Anyway, this should be the answer result, and the correct choice is C. C is the correct choice. Okay, let's do problem number 9. If x degree is the smallest possible obtuse angle of each interior angle of a regular polygon, and y degree is the maximum possible exterior angle in a regular polygon, what is the value of x degree plus y degree? X degree is the smallest possible obtuse angle of each interior angle of a regular polygon. So it is talking about a regular polygon. X degree is the smallest possible obtuse angle interior. So in a n-sided, we know that in an n-sided regular polygon, each interior angle, each interior angle, I'm abbreviating as EIA, will be equal to 180 degree multiplied by n minus 2 divided by n. So this is an interior formula for an interior angle of a n-sided regular polygon. Now it is saying that x degree is the smallest possible obtuse angle. So when can this be interior angle will be obtuse? Obtuse means greater than 90 degree. Smallest possible obtuse angle. Smallest possible obtuse angle. So now if each interior angle to be obtuse, or not if but for each interior angle to be obtuse, we must have its value should be greater than 90 degree. So EIA, each interior angle should be greater than 90 degree. Now this implies the formula for each interior angle of an n-sided regular polygon is 180 degree n minus 2 divided by n. This should be greater than 90 degree. We are just trying to find the n so that each value of each interior angle is greater than 90 degree, but it must be the smallest obtuse angle. So it has to be greater than 90 degree. So we have to, from this inequality, we have to find the least value of n such that the LHS will be greater than 90 degree. Now we have similarly, as I explained in some previous example, how to solve inequality. In this I can cross multiply. So this will, from here I can say 80 degree multiplied by n minus 2 will be greater than 90 degree multiplied by n. I just in an inequality like this, you can cross multiply. So I will have 180 degree multiplied by n minus 2 will be greater than 90 degree multiplied by n. You can also, I just cross multiplied. You can also think it like this, that I have multiplied both the side by n. So I have this. Now this implies, if I simplify the left hand side, it is 180 degree multiplied by n minus 360 degree is greater than 90 degree multiplied by n. Now in inequality also you can transpose items, that is, you can, not items, terms, you can transpose terms from one side to the other side. So I am transposing the minus 360 degree to the right hand side, and I am transposing the RHS to the left hand side, and I will get 180 degree multiplied by n minus 90 degree multiplied by n should be greater than 360 degree. So this will imply, if I simplify the left hand side, 180 degree multiplied by n and 90 degree multiplied by n, this is nothing but 90 degree multiplied by n should be greater than 360 degree. So from here I can say that in this inequality I will divide both sides by 90 degree. So I will have n greater than 360 degree by 90 degree. This means that n is greater than 4. So if I have to have in a regular polygon of n side, if I have to have if I have to have each interior angle greater than 90 degree, I must have n greater than 4. N greater than 4. So this implies the least value least possible value of n is equal to 5. N is greater than 4 and n are natural numbers, so n can be 5. Now, so n is 5. It is asking what is the smallest possible obtuse angle of each interior angle of a regular polygon. So if n can be 5, so this implies for n equals to 5, each interior angle becomes 180 degree 5 n minus 2 5 minus 2 divided by 5. This is 180 degree divided by okay, so this is 180 degree multiplied by 3 divided by 5. This is 36 degree multiplied by 3, which is 108 degree. So this is the smallest obtuse angle of the interior angle of a regular polygon, and definitely for that regular polygon the n is 5. That is, regular pentagon has the smallest interior angle which is obtuse, and that value is 108 degree. Okay, so we have so far found x degree is equal to 108 degree. So now we have to find y. What is y? And y is the maximum possible exterior angle in a regular polygon. Maximum possible exterior angle in a regular polygon. Now remember that let's say we have some regular polygon. Oh, it is coming square. Sorry. So let's say this is a regular polygon. It is a very weird figure. So we know that it is asking y degree is the maximum possible exterior angle in a regular polygon. So let's say this is a regular polygon of some number of sides. As you can see, this is 1, 2, 3, 4, 5, 6. This is a regular hexagon. But in general, in a regular polygon, so this is one exterior angle. So let's say this is p degree. This is exterior angle p degree, and its interior angle will be, this is q degree. Now please note that if you want to increase p, if p increases, then q will decrease, because p degree plus q degree is always a constant, that is 180 degree. Exterior angle, sum of exterior angle and corresponding interior angle of any polygon is always 180 degree. So p plus q will be 180 degree. If you increase p, keep on increasing p, q will decrease. So maximum, so I can say that maximum possible value of the exterior angle, that is p degree, will imply minimum possible value, because when p is maximum, then obviously q will be minimum. So it will be implies minimum possible value of q degree. And what is q degree? Q degree is the internal angle of the regular polygon. Q degree is the internal angle of the regular polygon. So now if we can somehow find the q degree, that is the minimum possible value of q degree, that is the minimum possible value of the interior angle of a regular polygon, then we can find the corresponding maximum possible exterior angle. Now we know that for a regular polygon of n side, each interior angle is equal to 180 degree multiplied by n minus 2 by n. Now when can each interior angle is this, okay. Now when can this value be minimum? Now n, where we know n can take values 3, it will start from 3, it can be 4, 5, 6. When at which value of n this interior angle, that is 180 degree multiplied by n minus 2 divided by n, will be minimum. We are trying to find the minimum possible interior angle of a regular polygon. So if n is the number of sides of the regular polygon, each interior angle is 180 degree multiplied by n minus 2 divided by n. So what value can n have so that this whole angle will be minimum? So let's see, for n equals to 3, EIA, each interior angle is equal to 180 degree 3 minus 2 by 3, which is 60 degree, okay. For n equals to 4, each interior angle is 180 degree 4 minus 2 divided by 4, this is as you can see 90 degree. So it is increasing, as you can see, as we are increasing n, the each interior angle is increasing. So definitely we can say that EIA is minimum for n equals to 3. This implies minimum EIA is equal to 60 degree, which is, so minimum interior angle is 60 degree. So now we can say this implies maximum exterior angle possible in a regular polygon. Maximum exterior angle will be equal to 180 degree minus the minimum interior angle, that is 60 degree. So this is equal to 120 degree. This is equal to y degree. Y degree is 120 degree. Okay. So we have x is equal to what was x? 108 degree. So this implies x degree plus y degree is equal to 108 degree plus 120 degree. This is equal to 228 degree. This problem was a bit conceptual problem. So the correct choice is C. C is the correct choice. Okay, let's do the last problem. Question number 10. In the polygon ABCDE, okay, let's quickly draw the polygons. It's a polygon. It's a simple polygon. Okay, so we have something like this. Okay, A, B, C, D, E. ABCD is a polygon. AB is parallel to DC. Okay, so AB is parallel to DC. Angle A is 3x degree. Angle E is 4x degree. Angle D is 3x degree. Okay. Then the value of x is, we have to find the value of x. Okay. So this is a polygon. So this is a 1, 2, 3, 4, 5-sided polygon. 5-sided polygon. Okay. AB is parallel to DC. AB is parallel to DC. AB parallel to DC implies that AB is parallel to DC and BC is a transversal. We can say BC is a transversal. BC is a transversal. This will imply that this angle and this angle are supplementary. That is, angle B and angle C are co-interior angles. We will have angle B plus angle C is equal to 180 degree. Okay. Also we okay. Also angle A, this is a polygon of having 5 sides. So we must have angle A, all the angles, sum of all the angles in this polygon should be equal to, we know that the formula, the sum of all the interior angles of a convex polygon with n sides is 180 degree multiplied by n minus 2 by n minus 2. So over here we have n is 5. This is the sum of all the angles of the pentagon. So this is a pentagon basically. 1, 2, 3, 4, 5 pentagon. Okay. So this is equal to 540 degree. Okay. Now B plus C we know is 180 degree. So this will imply that angle A plus angle D plus angle E will be equal to 540 degree minus angle B plus angle C. This is equal to 540 degree minus B plus C is 180 degree. So this is equal to 360 degree. Okay, 360 degree. Okay, 360 degree. The sum of the angles, the sum of the values of the angles A, D and E is 360 degree. Now the angle A, D and E are already given in terms of x. So we have 3x degree plus 3x degree plus 4x degree is equal to 360 degree. This implies, simplifying the LHS, we have 10x degree is equal to 360 degree. So this implies 10x is equal to 360. This implies x is equal to 360 by 10, which is 36. So x is 36. Correct choice is D. So with this, it comes to an end in solving the problems of chapter test number 1. This was a revision test based on the chapters of polygons, quadrilaterals and parallelograms. I will make another test which will be chapter test number 2 on the same chapters, polygons, quadrilaterals and parallelograms. I hope these set of problems will give you a good practice and judgment of your understanding on the concepts of these chapters. If this video was beneficial, then please like it, share it with your friends, and once again please support me by subscribing to my channel, and also do not forget to press the bell icon so that you will be notified by my future videos. Once the next chapter test number 2 is complete, I will I will start the next chapter. I don't know which it is, what the chapter is, but parallelly also I will keep on solving 5 good problems on these chapters. 5 good problems will be based on these 3 chapters, polygons, quadrilaterals and parallelograms, in the other playlist, that is Maths 8 Hot. So please stay tuned for these videos coming soon. I will end the video here. Thanks for watching, and until the next video, take care and bye.